Hello everyone, and thank you so much for joining us for this webinar tonight on nutrition and immunity, which has been very kindly sponsored by Purina. Now, before we start, I just want to go through a few things to help you get the most from this session, especially if you are new to our webinars. You can see a few new faces here, so maybe this will just help you a little bit as we go along. To the right of your screen, or just below, if you're on a mobile device, you'll see a tab called Resources. If you click in there, you will be able to access your downloadable CPD certificate and a PDF of tonight's slides. They will remain there for the duration and afterwards as well. If you have any technical difficulties, then first of all, just try refreshing your page. There is also a test your connection button, so you can also try that, and that will also take you through to technical support should you need it. Hopefully not, though. The session is being recorded, so don't worry if you miss anything at all. You will receive an email about this time tomorrow with the link to watch again, and again, you'll be able to get your certificate and your PDF of the slides again at that point as well, so no rush to do that now. We will have time for questions at the end, so if you think of anything at all you'd like to ask, then please type your question in the Chat Now box, which is in the bottom right of your screen, and you can do this at any time during the webinar, so as soon as you think of something, please do type it in there. Whilst I have you here as well, I just want to take this opportunity to mention ISFM membership, which is available for both vets and nurses or technicians. As part of the VET membership package, you not only get access to our exclusive monthly webinars, but also to our journal, JFMS, which is a fantastic resource. VET members also can access all of the benefits of nurse membership. So for nurses, we have a separate webinar program and a nurse journal called Feline Focus. So brilliant resources, and if you're not a member, then please do pop over to our website for more information and to sign up. But don't do it quite now, as I would like to introduce our speaker for tonight, Dr. Ebenezer Satyaraj. Now, Ebenezer is a leading expert on nutritional immunology and is a director of molecular nutrition at Purina. So I'm absolutely delighted that he's agreed to share some of his knowledge and insights with us today. So without further ado, over to Ebenezer.
Hello, it's my pleasure to be talking to you about emerging paradigms in immunonutrition. My name is Dr. Ebenezer Satyaraj. I'm Director of Molecular Nutrition at Nestle Purina Research based in St. Louis, Missouri. We will be discussing the relationship between nutrition and the immune system and how we can leverage those relationships to be able to enhance the immune health of both pets and people. This is a pretty complicated slide, but essentially it illustrates the various cell types and processes that are involved in initiating an immune response. For example, you have the antigens from bacteria and viruses that are picked up by macrophages, presented to T cells. T cells recognize those antigens, proliferate, and then activate B cells to be able to make antibodies against those T cells. Pretty interesting, complicated relationships, but essentially the immune system can be boiled down into three functions, and how it accomplishes those three functions by asking two fundamental questions. Let's take a look at that in the next slide. The immune system has three important functions. First, it keeps the bad stuff out, which is the barrier function. The second, it keeps checking if something has gotten through the barrier, which can be called as the surveillance function. And the third, it deals with intruders, which is the defense function. And in this context, certain parts of the body that we typically don't think of as the immune system, things such as skin, epithelial lining, saliva, secretions, various bodily secretions which have the ability to keep bad stuff out, could also be classified to be part of this overall immune system that the body has, with the primary role of protecting ourselves, itself, from pathogens and invaders. The immune system accomplishes these three functions by asking two fundamental questions. The first question is this me? And herein lies the idea of self versus non-self. In other words, the immune system is clearly able to recognize an intruder or a pathogen and is able to defend ourselves from that, but it does not react against a protein that is self. And once the answer for is not me, the immune system then goes into trying to define ways to be able to protect ourselves from that intruder. And this is where, depending upon the situation, the immune system can take an inflammatory pathway, which is typically called as a Th1 route, or other pathways where this is more antibody-based defenses using a Th2 pathways. But in a sense, the immune system provides three primary functions: the barrier function, the surveillance function, and the defense function, and it carries out those functions by asking two fundamental questions: is this me? And if it's not me, what am I going to do about it? In this webinar, we'll answer three questions: why enhance immune health? How can food influence the immune system? And what's the framework of the relationship between food and the immune system? Answering the first question. What I have in this slide is a diagrammatic representation of a dog during its various life stages, how it's able to fight an infection. And what you can clearly see is that both a puppy and a senior dog tends to have a lower immune response as compared to an adult dog. And this is true for humans, this is true for cats, this is true for all mammals. That's one of the reasons why when you have the influenza epidemics or influenza season beginning, we typically ask young children as well as older people to have vaccinations so that they're able to protect themselves from these infections. So clearly in these two life stages, there tends to be lowered immune response. And again, it's important to mention that there is no disease in either of these cases. It's just a function of their life stage. There are also other reasons where immune systems or immune responses can be suppressed. These include stress, fatigue, and disease. Stress and fatigue are two different things. Stress is things that happen during one's life, during the lives of a dog or a cat, that can temporarily depress the immune system, and we'll see a couple of quick examples of that. Fatigue is a very different situation where you go through extreme exhaustions. For example, people have shown in studies that people who trained for extreme marathons can eventually end up impacting negatively their immune system, so that they tend to have lower immune response for the rest of their lives. They almost never are able to recover and come back to their normal levels. So that's a completely different context, and we'll not be talking about it in this webinar. The other situation that can suppress an immune response are diseases, which, as you all know, depending on what disease the dog or cat may have, that can end up suppressing their immune response. And our primary focus in the webinar today is on healthy animals. So we'll be really talking about life stage, which you saw in this slide, and then the effects of stress. This slide describes the immune response in a puppy. Neonatal immune responses or immune responses in a puppy are typically lowered. There have been papers published that shows that the proliferative ability of newborn puppies tend to be half of that of an adult. Immune response in a puppy also tends to have a Th2 bias. And when we talk about Th2 bias, what we're referring to is that instead of mounting an effective inflammatory response against a pathogen, the immune response tends to be a little weaker, and therefore these puppies tend to be much more vulnerable to infections. If you dig down and try to understand the reasons for this, there are three primary reasons. One, inefficient antigen presentation by a key cell type called macrophages, because these cells are not fully developed in a puppy. Second, there is the influence of the fetoplacental environment. As you're all aware, during the late term of any pregnancy in a mammal, there seems to be an immunosuppressive effect, which is what enables the mother to be able to carry the conceptus all the way to a full-term pregnancy. And some of those hormones that induce those immunosuppressive effects in the womb tends to linger on during puppyhood as well. And finally, the immune cells of the puppies are not fully developed. So the Th1 T cell types, these are T cell types that are important to mount an effective inflammatory response. They tend to go through apoptosis, a process called as programmed cell death once activated. So these are some of the key reasons why the immune response in a young animal tends to be lower than that of an adult. In this slide, we're talking about the immune response in an older animal. And just because I have a picture of a dog, it doesn't mean these things don't apply to the cat or to the human or the horse. This is universal across all mammals, and that is true for the earlier slide as well. When we were talking primarily of puppyhood, we're talking about young animals, and this is true for dogs and cats. So let's take a look at what happens to the immune system when an animal ages. The immune response in an older animal is characterized by lower responses. There is a declining hematopoietic ability. In other words, the proliferative ability of the cells of the immune system are suppressed. There is also atrophy of the thymus, which is an important organ in the immune system. There is increased oxidative stress and lowered low-grade inflammation. Both these things tend to act together and cause a phenomena called as immunosenescence. In other words, immune cells in an older animal tends to have lower ability to respond to a challenge. Just as we saw in our earlier slide, if you look at and try to understand the reasons for why the immune response in an older animal is lowered, you again come across the same thing, which is inefficient antigen presentation by the same cell type, macrophages. And then, of course, you have cellular changes, such as suppressed proliferative ability and increased apoptosis, programmed cell death, which also tends to be increased when an animal gets older. In the last two slides, we covered the two extreme examples of life stages where, as we saw, there tends to be lower immune response, young animals and older animals. Let's move on to the effects of stress on the immune system. Now, stress can have a significant negative impact on the immune system, and there are some very interesting studies that have been conducted with this regard. One study in particular that I'd like to talk about here is a study that was done by Glasser et al. And in this study, they conducted vaccine response evaluations of two groups of young students. These were medical students. One group were getting ready for a board exam, and the other group did not have that stressor in their life. And when both these groups were administered the same vaccine and their response is evaluated, the group of young medical students who were preparing for the board exam had a significantly lowered response to the same vaccine as compared to the other group of students who did not have the stressor in their lives. To give you a little more context, vaccine response is an effective way for us to be able to evaluate the immune status of a human or an animal without actually exposing them to an infectious agent. And it is used in many immune studies. And we'll see some examples of those in the studies that we'll be discussing today as well. What's interesting about stress is that the effect of stress, the negative effect of stress on the immune system, is irrespective of age. Because there is another group that did a study where they now evaluated the immune response in older adults. And again, we have two groups of older adults, one group that had a stressor in their life, and this group of older adults were taking care of a partner who had dementia. And the other group did not have that stressor in their lives. And again, as we saw with the study with the young medical students, when we asked and looked for vaccine responses from the older adults who had a stress in their life, they saw exactly the same findings where stress can significantly reduce the vaccine response to a same vaccine, whereas if they did not have the stressor in their life, they had a normal immune response to the same vaccine. This goes to make the important point that stress, irrespective of age, can have a significant negative impact in their lives. If you start looking at the reasons for stress negative impact on the immune system, you come across again two main categories of reasons. One is inefficient antigen presentation by the macrophages, and the second, hormones, stress hormones that is typically produced and present during a stressful situation or stressful event, hormones such as glucocorticosteroids, epinephrine, norepinephrine, etc. All these things can have a significant negative impact on the ability of immune cells to proliferate. What I have in this figure is a Venn diagram where I've tried to capture the various reasons that explain why the immune response is lower in a young animal, in an older animal, and when there is stress in their lives. And as you can clearly see, the common factor that affects and causes lower immune response in all these three situations tends to be inefficient antigen presentation ability of the macrophages. And therefore, macrophages tend to be an interesting target for us to be able to look at in helping address and reverse these lower immune responses observed in these three different situations. To recap, life stage, neonatal stage, and old age, as well as stress, can lower the immune status. And one of the common reasons in all these situations tends to be inefficient macrophage function. Let's move on and try to answer the second question: how can food influence the immune system? Immune system can be impacted by the genetics of the pet. As we know, certain breeds tend to have lower or immune challenges. Life stage, as we saw in our discussions earlier, and lifestyle. There are three components to lifestyle. One is good nutrition, second is an involved pet owner, and third are veterinarians in the good medical care, vaccinations, etc. that is being provided for the pet. The relationship between nutrition and the immune system can be understood at 3 to 4 levels. The first level is where you're providing complete and balanced nutrition, which is very essential to be able to have a healthy immune system. We take complete and balanced nutrition for granted, but it is important to remember that even in the human context, where you have war, famine, or natural disasters, and nutrition becomes scarce, populations tend to have lower immune response and become susceptible to very simple infections. So it is important that you always begin with a complete and balanced diet. The second stage is you're optimizing certain key micro and macronutrients. These examples would include proteins, vitamins, minerals, etc. But it is important to remember that in both these stages, you are passively giving nutrients for the immune system to be able to take up and provide an effective immune protection. Stage 3 and stage 4 is more active engagement with the immune system. In stage 3, you're actively immunomodulating the immune system by challenging the immune system with innocuous and yet things that can activate the immune response, such as probiotics or other ingredients that can stimulate the immune system without actually exposing it to an infectious threat. What happens during this process is that some of the networks that are important to be able to mount an effective immune response are rehearsed and strengthened so that when an actual immune response or immune challenge occurs, the immune system is able to respond much more effectively. Stage 4 is a completely different approach where you're trying to personalize nutrition to address a specific immune issue. A great example of that would be able to induce local immunosuppression in an inflammatory bowel condition, where you could have dietary approaches to be able to suppress inflammation in the gut. And we will see quick examples of each of those in the rest of the talk. Stage 1 is self-explanatory. When we talk about stage 2, the key components that seems to be important for the immune system that needs to be increased are high-quality protein, vitamins such as vitamin A, C, and E, and minerals such as zinc, magnesium, and iron. Certain calorie restriction strategies also fall in this category, as well as antioxidant supplementation to be able to counter oxidative stress and the self-inflicted damage from free radicals. Prebiotics that support a healthy microflora also fall in this category. In active immunomodulation, what you're doing is enabling efficient macrophage function by targeting receptors of the innate immune system in the GI tract using microbial immunomodulators such as beta-glucans, mannans, microbial nucleic acids and proteins, peptidoglycans, probiotics, cyanobacteria, algae, etc. All these are recognized as potential pathogens, and as we can clearly see, these do not have the ability to infect and cause damage, but yet can stimulate an immune response to be able to establish those key networks that are essential to be able to mount an effective immune response. Other immunomodulatory ingredients such as bovine colostrum and whey proteins also fall in this category because they also interact with these same receptors and activate the immune response. Also, strategies that are used to control inflammation, such as DHA and omega-3 fatty acids, would also fall in this category. Let's discuss an example of active immunomodulation. And what we'll be talking about here is the use of bovine colostrum for immune and gut health. This is the outline of the kitten study that we'll discuss. The study included 24 European short-hair kitten. They were 12 weeks of age. They were divided into two groups. One group was fed a ProPlan kitten control diet, and the second group was fed a ProPlan kitten test diet that had bovine colostrum supplementation. The trial lasted for 44 weeks and were conducted at St. Joseph, Missouri facility, and we had immune and gut health measures taken during the study. Here's a schematic representation of the study. Both groups of kitten were fed a pre-test diet for 4 weeks. Just before the test group was shifted to the test diet, they were administered a rabies vaccine. And then at week 38, a rabies booster vaccine is provided. We had monthly samplings of blood and fecal samples collected to be able to measure various immune and gut health parameters that's listed in the next slide. Immune analysis included evaluation of the systemic immune response by looking at rabies vaccine response, plasma immunoglobulins, and serum amyloid A protein as a marker for inflammation. Local immune response in the GI tract was evaluated by measuring fecal immunoglobulin A. Gut health measures were carried out to be able to profile for gut microflora similarity and diversity, as well as other routine measures such as blood profile and body weights were conducted as part of the study. In this slide, you're looking at the systemic immune response in these kittens that were fed a diet supplemented with bovine colostrum. On the y-axis, you're looking at rabies vaccine titers, and the x-axis, weeks of trial. And as you can clearly see, from week 36 onwards, the test diet by week 40 had significantly higher responses to the rabies vaccine as compared to the control diet, clearly demonstrating that these kittens were able to mount a much more effective immune response as compared to the control group. This slide shows a very similar phenomenon, but you're looking at the local immune response in the GI tract. And what you can clearly see when you look at the normalized fecal immunoglobulin A levels, the test group had significantly higher levels of fecal immunoglobulin as compared to the control group. Fecal immunoglobulin plays an important role in protecting dogs, cats, and us from various pathogens that go through our GI tract. And therefore, higher levels of fecal immunoglobulin always refers or indicates a stronger immune status, a stronger immune response, a stronger ability to be able to fight infectious diseases. A strong immune system is often reflected in greater microbial stability in the GI tract. To be able to evaluate that, we used a model where we collected fecal samples from these kittens in the study before and after they were exposed to a very innocuous stress, which is being taken for a veterinary examination. And we then tried to look at microbial pattern changes before and after. And what we are really trying to evaluate is if they had a stronger immune system, they would be much more effective in able to suppress the microbial changes that often happens when a kitten or a dog or a cat is stressed. The results of this evaluation are shown in this figure. And what you're seeing on the y-axis is change in the microflora with regard to the baseline due to stress. And what you can immediately see is that in the group that was fed the control diet, there was a much greater change in the microflora pattern as compared to the test group that was fed diet supplemented with bovine colostrum, clearly demonstrating that kittens fed colostrum had much more stable microflora population in the GI tract. An important measure that we always do for all immune evaluation is to be able to document that the dietary intervention, in this case supplementing diets with bovine colostrum, does not cause any overt immunostimulation. To be able to demonstrate that and confirm this, we measured serum amyloid A, which is a protein that increases in the plasma during inflammation. In a normal cat, when there is no inflammation, the levels tend to be between 0.3 to 3.6 micrograms per ml. But if the levels tend to go higher, that can go, if there is an inflammatory event, the serum amyloid A protein levels can go as high as 40 micrograms per ml. And what you can see in the figure clearly shows that in both groups, there is no signs of overt immunostimulation because the level of serum amyloid protein both in the test group as well as the control group tends to be well within the normal range, clearly demonstrating that the immune system in the kittens that were fed diet supplemented colostrum are not hyperactive. They only respond when they are challenged, as we saw in both the vaccine response as well as the enhanced fecal IgA that we observed in these kittens. To summarize, what the studies show is that diets supplemented with colostrum enhance immune status, enhance local immune response in the gut-associated lymphoid tissue, also called as GALT, increased gut microflora stability under stress. There is no overstimulation of the immune system as seen in the normal levels of serum amyloid A protein seen in both the test and the control group. And of course, we don't have data shown here, but there was no negative or no effect on body weight or blood profiles. Let's take a look at another example of active immunomodulation. In this case, we'll walk through a study where we show that supplementing diets with probiotics significantly increases immune and gut health. Here's a quick outline of this puppy study. It involved 14 puppies. They were 8 weeks of age. They were fed 2 diets, a controlled diet, which was Friskies Alpo, and a controlled diet that was supplemented with Enterococcus faecium, SF68, at the dose that's listed on the slide. This trial was also conducted in St. Joseph, Missouri, and lasted for 44 weeks. And during the trial, multiple immune and gut health measures were done to be able to document the positive effect of SF68 on both the immune status as well as gut microflora. This slide is a schematic representation of the study. And what you can see is that right before the test group was shifted to the test diet, they were administered a primary canine distempervirus vaccine. There was a booster vaccine that was administered at week 12. During the entire 44-week period, we had weekly blood samples collected to be able to evaluate vaccine response, and fecal samples were collected to be able to evaluate increased immune response in the GI tract. What you're seeing in this slide is immune response to the canine distempervirus vaccine. The top panel is looking at immune response in terms of IgG antibodies. In the lower panel, you're looking at immune response in terms of IgA antibodies. And what you can see in both those panels is that the group that was supplemented with a probiotic had significantly higher titers to the canine distempervirus vaccine as compared to the control group. What this clearly shows is that puppies that were fed SF68 showed enhanced immune status. In other words, they were able to respond much stronger to the same vaccine. In this slide, you're looking at local immune response seen in the gut-associated lymphoid tissue by measuring the amount of fecal immunoglobulin. And what you can clearly see is that puppies that were supplemented with probiotic had significantly higher levels of fecal IgA starting week 30 onwards as compared to the control group, again showing that they had not only enhanced systemic immune response as we saw in the vaccine data, but they also had enhanced local immune status in terms of increased overall fecal immunoglobulin. In summary, what you can see is that SF68 enhanced systemic immune response in its ability to be able to deliver a greater vaccine response. It also increased local immune response by the higher fecal immunoglobulin that you see in the puppies that were fed a diet supplemented with a probiotic. Having seen two great examples of active immunomodulation, let's look at some quick examples of the stage 4 interaction between the nutrition and the immune system, and that is examples for personalized immune nutrition. One of the approaches that people have considered is to be able to induce a local Th2 bias, which tends to be immunosuppressive as opposed to inflammatory, and that can significantly help in situations such as inflammatory bowel diseases. Ingredients that have been used for this include TGF-beta-rich ingredients that tend to induce local immunosuppression in the GI tract. People have also studied and are considered using probiotics that can specifically induce active anti-inflammatory cytokines in the GI tract to be able to suppress local immune response. These are really where the frontiers of immune nutrition are moving to, where you can, using nutrition, address very specific immune needs that the pets and even humans have. Let's now go back and try to fill in the answers for the 3 questions that we started this discussion with. The first question, if you remember, was why enhance immune health in an otherwise healthy animal? And the reasons are life stages, especially neonatal stage and old age can suppress immune status, as well as stress can suppress immune status. And those are the primary reasons you would want to enhance the immune health of an otherwise healthy animal. How can we use food to influence the immune system? And the secret lies in choosing ingredients that can target specific receptors on the macrophages to be able to induce an active immunostimulation without exposing the immune system to an infectious threat. And this is important because by doing that, you're actually reinforcing key pathways that are essential to be able to mount an effective immune response. And then, importantly, how do you understand the relationship between food and the immune system? We saw there are 4 stages. First is basic, where you're providing a complete and balanced nutrition or diet to the pet. Very important to begin with. In stage 2, you're trying to optimize key ingredients that are essential for the immune system. Examples of those include proteins, vitamins, and minerals. But stage 1 and stage 2 are passive because you're just giving high-quality nutrition for the immune system. In stage 3, you're actually making the immune system exercise. And this is where you're bringing in examples of ingredients that can stimulate the immune system and help it reinforce those critical pathways that are essential to be able to mount an effective immune response. We saw 2 examples of ingredients, one bovine colostrum, and the second probiotics. And finally, stage 4 is really where the future is headed. We are trying to use nutrition to be able to address a specific immune need. And the examples that we discussed was how can we induce local immunosuppression in the GI tract if the animal, or for that matter a human, has inflammatory bowel diseases. Examples of ingredients would include TGF-beta rich ingredients or probiotics that can specifically induce anti-inflammatory cytokines in the GI tract. All the ideas that we discussed here has been published in the paper that I've listed here. If you have time, I'd suggest you take a look at that. Thank you for your attention. I hope you enjoyed this webinar where we discussed emerging paradigms in immune nutrition and tried to understand how nutrition can impact the immune system. Thank you.
Wow, thank you so much for a brilliant presentation, Ebenezer. A really great reminder of immunity for us all, and really interesting to see how important nutrition plays, the role that nutrition plays in this. We do have quite a few questions that have come through, so I'm hoping that you will have a little bit of time to go through those now. Okay. I'm just checking. It just looks like we've just dropped connection from Ebenezer. I will just go through a few bits and hope that he manages to get back in the meantime, because we have got lots of questions and some really interesting ones there as well. So, yeah, we'll just wait and see if he can come back. If not, I can give you an email address. But I'm just watching the connection. It does seem to have dropped out for the moment. So apologies for that. Let's hope that he gets back in soon. Now, I hope you obviously enjoyed the webinar tonight. Don't forget that you will receive an email tomorrow which will have a link to watch again. So you can watch it all again. You'll also still be able to access your CPD certificate and the PDF of the slides. So around about this time tomorrow, watch out for an email in your inbox with the link, and then you'll be able to access all of that information again, so it's not lost forever. This is our last open access webinar for 2019. We hope that we will be able to bring you some more free webinars next year. We're working on a program at the moment. What we do definitely have booked in is some more webinars for this year, and already booked in for the beginning of next year for our members, so both our nurse members and our vet members. So if you enjoyed our webinar and you'd like to hear lots more webinars every month, then please do consider joining ISFM as either a vet or a nurse member. You can find all the information on our website. You can see previous free open access webinars are all on there as well, and you can also see the ones that we've got lined up for the members. So you'll be able to get an idea of what we can offer you if you do become a member, which we very much hope that you do. Unfortunately, it still looks like we don't have Ebenezer back on the line. He is over in the States, so I'm in the UK, Ebenezer's in the States. So we're doing this quite long distance, which is great, but unfortunately with technology, sometimes these things don't always work out as planned. So I think rather than keep everyone hanging on, I will just wrap it up. I'm just going to type, I can probably hear me doing it now. Oh, hello?
Hello?
Oh, hi Ebenezer, hi.
Hi Sarah, I just got a little delayed calling in.
Yeah, no worries. Okay, we've obviously got lots of questions that have come in, which is brilliant.
Okay.
I will just pick a few of them, otherwise we could be here probably for quite a long time tonight.
That's perfect.
There's obviously quite a lot of interest and excitement around the colostrum study that you talked about. So there's a few questions coming in on that one. The first one that we have is regarding the colostrum itself. Whether it was, if you know, did it come from factory farm cows or free-range cows? I don't know if you know that, the answer to that question.
I don't know the answer to that question. This was purchased from a supplier that produces and provides colostrum as an ingredient for several applications, including humans.
Okay, no worries. Yeah, that's fair enough. The second part to that question is, was the response due to the immunoglobulin in the colostrum specifically neutralizing pathogens?
That's a great question.
Yeah.
That's a great question. So what we believe or what we hypothesize is happening there is that besides just the immunoglobulin that's present in colostrum also has several other factors such as lactoferrin, which tend to have or have been demonstrated to show beneficial effects in not only suppressing pathogenic bacteria, but also potentially interacting with some of the receptors of the innate immune system. So what we believe is happening is a combination of ingredients such as, or components such as lactoferrin and antibodies present in colostrum cross-react with the Fc receptors that's present as part of the innate immune system in the GI tract and stimulate it. And that's what results in an overall activation of the immune system, as I described in the presentation, completely innocuous because you're not really exposing the immune system to a pathogen, but you're stimulating it, and that therein you build and reinforce some of the key pathways that are essential to mount an effective immune response. And that is then translated into what you saw the study in terms of enhanced vaccine response as a marker for systemic enhancement, as well as enhanced local immune response with regard to the fecal IgA increases that we saw in the kittens that were fed the test diet.
Excellent. Okay, yeah, that's great. Just going back to that study as well, there was a question about whether it was published or not. I know you gave some information about the next one with the puppies that you talked about, but with the kitten study, was that a published study, or was that somewhere where people can go to get that information?
The kitten study has not been published yet.
Okay.
It's been a couple of years since we finished it, but we have had some changes with people. Some of the people who did the study moved on to different roles. As a result, we haven't gotten it submitted as yet, but we are working on submitting it hopefully by early next year. But we did a
excellent.
very similar study with colostrum in dogs, and that was published in the British Journal of Nutrition, which I can quickly look up that paper as I'm talking, and readers can go. Very similar modalities in terms of the study. We obviously had to choose the appropriate markers for looking at immune measures because you're evaluating dog immune responses in this case.
Excellent. Okay, so the kitten study, that would be a really interesting one, obviously. So I think it's probably watch this space, isn't it, with that one for publication. Hopefully, like you say, early next year. That'd be fantastic.
Correct.
Because I think with the colostrum, it's really exciting because I think we kind of know about how important it is in newborn kittens to get that colostrum within sort of 24, 48 hours, but we don't kind of think about anything beyond that really, and I guess we don't also have that capability. So really interesting to see that actually as they grow, there is still a benefit to it. So that would be amazing to see that study when it is published, and how nutrition and kitten diets develop from there, really, isn't it? So amazing. Okay. So you talked about the study in puppies with the immune response to vaccines. Is there anything been done in cats on that side? So like with the puppy study?
You're referring to the puppy study with the SF68, the probiotic.
Yes, right, yeah.
We have done 7 studies with cats, and I'm not sure of kittens, but cats for sure. But I don't know if any of that has been published as yet.
Okay. So
as a general rule of thumb, while it is important for us to be able to document benefits of any ingredient that we use in the species, whether it's dog or cat or humans, generally speaking, immune modulating ingredients tend to have, if you have a benefit in one species, it typically tends to work in the other species as well. Of course, the doses will be different because depending upon the body weight, etc. But that's a general rule of thumb.
Right. Okay. Excellent. So, again, another study to watch out for. So great news there. It's all. I guess it's all kind of particularly for us, in general practice. It's all kind of this is an emerging kind of field, isn't it, that we're starting to see. Obviously, I guess that you've been working on this for a long time, but for kind of the general public or the general veterinary world, this is all quite new, very new and exciting to us. So obviously, people are keen to know more, and I'm sure that when those studies come out, that we'll start to be able to understand it and get that science as well, which will be amazing. So thank you very much for that. I'm just going to have a quick look, because there's a few questions just coming up about manano-oligosaccharides and whether they have any role in immunonutrition. At the moment, the colostrum side is in the diet is not generally an option, but we do have diets out there for kittens that claim to have support immunity, for example. So from what is currently available, is there anything that you would say is particularly important when we're looking at kittens and immunonutrition that is available currently?
I think probiotics is a very good start. So we do have colostrum in kittens, I believe, in some products in Europe, including ours. But probiotics is another thing to look at, because probiotics have shown to have tremendous immune benefits across multiple species. And again, there are different kinds of probiotics that you need to consider. One of the key things to remember about probiotics is what counts in most cases is to be able to have enough live bacteria or live bugs in the probiotics that you're feeding to your pet, because probiotics tend to be extremely sensitive to temperature changes. And if you're not able to ensure that your product retains a particular temperature level throughout the supply chain until it reaches your home, some of these bugs can be destroyed. So that is one thing to keep in mind, but try to, if you're using probiotics for your pet, try to get one from a reputable supplier that has guarantees in terms of the amount of live bugs that would remain at the end of shelf life of the product, so that you're giving the required dose to your dogs or cats, pups or kittens, to be able to get the immune benefits. There are other studies that I've done looking at ingredients coming from blue-green algae, spirulina. And going back to what I discussed in the presentation, all these are ingredients that are related to molecules that will be present, for example, on pathogens. And the immune system recognizes pathogens and bacteria that are harmless based on certain motifs. And these motifs are contributed by specific ingredients. And that is where how you choose those ingredients is how you design a diet that would have immunobeneficiary effect, because the immune system recognizes these ingredients as potentially pathogenic, mounts an immune response. Well, there is no real threat to the animal or the human, and thereby is able to activate an immune response, get all those pathways set up and established. That's the fundamental approach that we need to take. The ingredients that you'd select really would fall in that category. The colostrum, probiotics are very good things to start with. Brilliant.
Excellent. Well, thank you so much for your time. There are more questions, but like I say, I think we could be here for a long time, so we need to wrap it up for this evening. So once again, thank you so much for your time, Ebenezer. It's a brilliant presentation, really nice review of immunity, and exciting information there from the sort of colostrum and probiotic side of things in terms of what is to come and probably how nutrition for growing animals is going to change in the future, I would imagine, as well. So thank you very much for your time. We really do appreciate it. I would also... Yeah, brilliant. I also, of course, want to thank Purina, who have sponsored this session tonight. So thank you again to them, because that's been fantastic to be able to make this open access to everyone. Normally our webinars are for members only, but when we get sponsorship, then it means that we can open it up to everyone. And I can see that we have a lot of people from a lot of countries all over the world tonight, which is absolutely amazing, logging in and listening to find out more. So again, thank you to Purina. And of course, last but not least, thank you to everyone who has logged in. Thank you for your questions. Thank you for your time, for listening and your interest. And like I said earlier, this session is being recorded and everything will be available again, so you can watch back, listen back, and get all the information whenever you want to. So thank you very much. Thank you, Ebenezer. Thank you to everyone for joining us tonight. And until next time, goodbye.
Bye.